Yeah, thank you. Thank you. I'm good for now, but if it comes up again, I will. So we are doing project 6 on probability. And on our first slide, we just have some vocabulary. This is not really the best way for processing vocabulary, but I do want a record of reading these to you. And then as we go through our examples, hopefully we'll come back to some of these words. So trials is the number of times an experiment is repeated. So for example, if I wanted to find out how many heads I got if I flipped a coin 10 times, those would be 10 trials. Outcomes are the different results possible for one trial of the experiment. So in flipping a coin, your outcomes are heads or tails. In rolling a die, your outcomes are 1, 2, 3, 4, 5, 6. Sample space is the set of all possible outcomes for an experiment. So if you did an experiment where you were throwing a coin 3 times to see how many heads you got, then your sample space might include things like heads, 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 tails. Your sample space would be like a list of all the possibilities. Frequency, the number of times that the outcome is observed. So if you roll a die 10 times and you get 2 5s, then the frequency for 5s is 2. Relative frequency is that frequency as a fraction, the frequency of a given outcome over the number of trials. And probability is an estimate of the mathematical likelihood of an outcome occurring. So, basic rules of probability. The probability of any event is between 0 and 1. And think of that like in terms of percentages. So if I said there's a 100% chance that something was going to happen, then that would be a probability of 1. If there's a 50% chance, that would be a probability of 0.5. All the possible outcomes will sum to 1 or 100%. So if there is a 20% chance that I was going to give you a test this unit instead of a project, and an 80% chance that you were going to have a project this unit, those would add up to 100% or 1. The probability an outcome does not occur is 1 minus the probability that it does occur. So that might seem obvious, but that's actually a very useful strategy. For example, if I wanted to find the probability that I don't roll a 5, it might be more useful to know the probability of a 5 is 1/6 and subtract that from 1 to get that the probability of not having a 5 is 5/6. If no outcomes are in common, the probability that one or the other happens is the sum of both. So the probability that I roll a 3 or a 4 is 1/6 plus 1/6, which gives you a probability of 1/3. And when all outcomes are equally likely, the probability that A happens is the number of A outcomes divided by the total number of outcomes. And a lot of that is stuff that you may have learned in middle school, but it's just been a long time, and so it's a good review. Experimental probability is the number of times an outcome occurs divided by the outcomes, and this experimental probability is when you actually do the experiment, which may not match exactly the theoretical probability. It should be close though. So we're going to find some simple probabilities here just to get started. And I want you can do these in your head, or you can pull up Desmos if you want a calculator. If you have a bag of marbles containing 5 green, 3 red, and 7 blue, there are 3 probabilities. I'm going to read them to you, and then we'll go through them one at a time. What is the probability the marble that you pull is red? What is the probability the marble is not red? What is the probability the marble is green? So finding the probability that the marble is red, remember that there are 5 green, 3 red, and 7 blue. So take a minute and think of your answer for that one. You can go ahead to the other 2 as well. All right, so anybody have a solution for the probability that the marble is red? Okay, I heard a couple people say 3 out of 15 or 1/5. Is that right? Yeah, because there were 3 red marbles out of 15 altogether. And that can simplify to 1/5, or you can make it a decimal. Okay? All right, probability that it's not red. Say it again.
12/15.
All right, so how are you getting 12/15ths, Kenneth?
5 plus 7 is 12 out of 15.
Okay, so Kenneth did 5 plus 7 because those were the not red marbles. Did anybody use a different strategy? Is there another strategy we could use besides adding the green and the blue marbles? Oh, Kylie, sorry. Good. All right, so Kylie says you could also subtract the red marbles from the total outcomes, right? So if we know that there's 15 altogether, you could subtract the 3, and then you would also get 12. So not red is 12 out of 15, or 4/5, or 0.8. Right? And remember that the red and the not red have to add up to 1. And does it work? Do they add up to 1? Good. All right, probability that your marble is green. What's that one going to be? Okay, I've got 1/3 from a couple people. And some of you may have started with 5 out of 15 and then made it 1/3. All right, so we kind of all have different experiences with probability. For some of you, you're thinking, you know, this is pretty easy. I've got this. For some people, it's just been a long time, or maybe like in middle school, your class skipped over that. So we're all in slightly different places, which is why we have to review this. But I do promise that we will be getting to some harder probabilities, mostly in days 2 and 3, but maybe a little bit today. All right, probabilities of independent events. To find the probability of independent events, which is when the outcome of one doesn't affect the outcome of the other, we use the outcome method. There's another method too, I'll show you both. So for the outcome method, you list the possible combinations of the event, and then if there's more than one way that you can have a success, you'll add them up. And then, you multiply for the different events, and then you add up the different ways. And that seems like a lot of words that don't make sense, so I'm going to show you the example. So if you wanted to find the probability that you would get 1 head, exactly 1 head, when you flip the coin 3 times, the 3 different outcomes you could have are heads, tails, 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 heads, tails, or tails, tails, heads. So to find the probability of heads, tails, tails, the probability that the first one is heads is 1/2. The probability that the next one is tails is 1/2, and the probability the next one is tails is 1/2. You multiply those, and you get a probability of 1/8 that you're going to get heads, tails, tails. All right, the same thing happens for tails, heads, tails. 1/2 times 1/2 times 1/2 is 1/8, and tails, tails, heads. 1/2 times 1/2 times 1/2 is 1/8. Now there are 3 different ways you could get exactly 1 heads. So you're going to add up those 3 different probabilities now. So there's a 1/8 chance of each of these, and if you add them up all together, there's a 3/8 chance that you will get exactly 1 head, which is pretty good. It's just a little bit less than half. All right, sometimes when the sample space is small, you might choose to do the sample space method instead, because it's just a lot less adding and multiplying. So the sample space method is when you list all of the possibilities. So in my sample space, I have heads, 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 tails, heads, tails, heads, tails, heads, heads, tails, 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 heads, tails, heads, tails, and heads, tails, tails. Those are all the possibilities from flipping your coin 3 times. So then if you look at them, you can circle the ones that have exactly 1, it was supposed to be 1 head, right? Did the wrong thing. All right. Exactly 1 head, right? So none in the first row. Actually, it's just these 3. Okay, so there were 3 that had exactly 1 head out of 8 altogether. All right, so think about the outcome method versus the sample space method. For this problem, did you guys prefer the outcome method or the sample space method? Which one seemed more natural to you? Which one did you like?
Sample space.
The sample space one? Anybody else like the sample space one better? Brian did? Good. All right, and anybody like the outcome methods better? Kyle and Gabe like that one? Yeah, sometimes I like to actually think of the problem both ways, because with probability, you can sometimes confuse yourself. even if a problem seems straightforward, it is very possible to misreason with your probability. And so by looking at it both ways, I can be sure I got it right. Can anybody think of a time when the sample space method might be more difficult? Ireland?
If you have like more to work with, like if it was asking, if you flipped a coin 15 times,
Right.
it would be a little more difficult to.
Yeah, no, that makes total sense to me. If you flipped a coin 15 times, your sample space would be gigantic. And so you wouldn't want to have to write all that out. Yeah. So in that case, you might prefer the outcome method because it might be easier. It's good. All right. So we have some practice here. If you toss a fair coin 3 times, what is the probability you will get 2 or more heads? And if you toss a fair coin 3 times, what is the probability you will not get 2 or more heads? So I'm going to pause for a minute so you can think about those. You're tossing the fair coin 3 times, probability you get 2 or more heads.
That would be 2 heads, so you have 2 heads and then tails.
Uh-huh.
The tails ahead, and the tails and 2 heads.
Okay.
And I initially forgot getting 3 heads.
Oh, yeah.
Then when I went back, I saw it. So when you do the method you did on the first slide, 1 half times 1 half times 1 half.
Uh-huh.
Those, and then you add them all up and you get 4/8. So.
Okay. So yeah, it was very similar to this one right here, except if you switch the heads for the tails, right?
Yeah.
And so you would have 1/8 plus 1/8 plus 1/8, and then he says you have to add in that extra 1/8 for the heads one. If you're looking at the sample space, it would just be the top half, right? That has it. Yes.
I have a question about the outcome method.
Go ahead.
So, you have like the number of 1/2s based on how many times you flipped a coin.
Yes. Yeah. So when you have independent events, and you can actually mix. So I could say, what's the probability that I flip a coin, get heads, roll a die, and get a 6? Like that's going to be my entire event there. And you would have 1/2 for the head, and you would have 1/6 for the die, and then you would multiply those to get 1/12 probability that they would both happen for you. All right. So we said for this one, the probability was 4/8, which is 1/2. And then what's the probability you will not get 2 or more heads? So they have to add up to 1, right? So yeah, the probability that you do not get 2 or more heads should be 1 minus. But let's check that with the sample space. So it should be 1 minus 1/2, which is 1/2. So let's just check 2 or more heads. So these are all 2 or more heads, right? And then down here, these are going to be less than 2 heads. Yeah, good. All right. All right, so going back to the bag of marbles, the marbles still have 5 green, 3 red, 7 blue. So now we're going to find some ors. So we have red or blue. Then we have green or not red. And then we have neither green nor blue. So let's focus first on red or blue. Remember that we have 5 green, 3 red, and 7 blue. And then if you finish with that quickly, you can do the others. All right, raise your hand if you have the probability that it is red or blue. 1 hand. Should see more. 2 hands. 3 hands. All right, Kamar, what did you get for red or blue? Anybody else think 10 out of 15 is accurate? Excellent, good. And did anybody simplify it? To what?
It's 2/3.
2/3? Okay, good. So 10 out of 15, great. And 2/3, beautiful. All right, what's weird about green or not red? Why is that a weird question? Yeah, so there's some overlap, right, between those. So green or not red, you could really just say not red, right? That would include all of the greens. Yeah, but sometimes they ask tricky questions like that because they're waiting to see if you like overestimate. Did you count the greens twice, right? You can't do that. So what is our probability here? What do you guys get? Ireland?
12 out of 15.
Anybody else get 12 out of 15? Very good. So there are 12 that are not red, including the green ones. And what does that simplify to?
4
Good. And then we've got neither green nor blue. So if it's not green or blue, what is it? It's red. Good. So that would give us 3 out of 15, or 1/5. Okay. So just a little bit of fraction work. I am perfectly happy with decimals as long as they are either exact or rounded correctly. So we have an activity in Schoology, and I'm going to have you guys go to that. And in that one, you're going to be doing both theoretical and experimental probabilities. So theoretical is what we were doing just now, and experimental is when you actually try it yourself. Now, if you do not feel comfortable like using shared equipment, then there is a simulator online, and that should be linked in your document. But if you would like to, it's kind of fun to actually do the penny flipping and the dice rolling. You may work with a partner on this activity if you like. It is not like a project partner, just a partner for today if you would like to work with somebody, or you can do it yourself. But when you're like rolling dice and flipping coins, then it's kind of fun, okay? So I'm gonna have you guys open your activity up, decide if you're gonna work alone or with a partner. If you're gonna work with a partner, share the document. Dave, I'm gonna put this on your desk for you. There's a die and there's a penny. And if you would like to use actual materials, they are right here. You can come and take a die and a penny. Or if you want to use a simulator, that's gonna be linked in there. Any questions? All right, and please let me know if you're going to need some help making up any work before the end of the quarter. For this class, we're going to have 2 classes this week and 2 classes next week. But for your Blue Day classes, you don't have as many classes left in this quarter. So you might want to be thinking also about your Blue Day classes and what you want to make up before the end of the quarter. Because this week, you've got 3 blue days. Next week, your only blue day is an RCO day. Okay? All right, so go ahead and borrow materials. I think it's more fun that way.
Just one die.